Okay, so today we're going to cover our last lesson on chapter 2, dealing with graphing rational functions. So before the break, we worked on finding the vertical and horizontal asymptotes of rational functions. What we're going to do today is utilize that information to help us sketch the graphs. So the only new vocabulary we're getting is what a slant or oblique asymptote is. This is a scenario we did not talk about in the last section. It is an asymptote that follows the equation of a line, y equals mx plus b. So you need to divide the polynomials when the numerator has the higher power. So when we looked before, we talked about when they have equal power, we get that horizontal asymptote that is essentially just reducing it. If the denominator is a greater power, it's just y equals 0. Well, when the numerator has a higher power, it's actually going to be a line y equals mx plus b, and we'll just use polynomial division. I think every example I give you can actually be done with synthetic. I don't think there were any that were like, oh, 2x plus 3. I think they were all divided by something simple like x plus 1 or x plus 5 or x minus 3. So you could use synthetic division to get us there. So here's what we are going to do to help us graph each time. These are the 4 steps we want to follow. So list the guidelines for sketching these for any rational function where n of x is the numerator and d of x is the denominator. Simplify if possible. Factor what we can. If things cancel, they make a whole. So remember when we had 2 things that canceled out, that ended up giving us a hole in the graph versus having an asymptote at that spot. Sorry about that. Here, find the horizontal or slant asymptote and graph them. Then we are going to set the denominator equal to 0 and solve, graph the vertical asymptotes. So we're going to graph all the asymptotes before we actually graph the smooth curves along the asymptotes. That's our last step. So we're actually going to do all this work that we did before break in section 2.6 with finding our asymptotes. We're now going to take the time to graph them. And after we graph them, we're going to go, okay, here's where our curves go. So let's look at this in motion. Now, if you did not have time to write this all down, it is on our notes on Schoology. They are posted and ready to go for us. So let's sketch the graph of this equation here. So again, step 1, so simplify as possible, factor what we can. Okay, numerator is as simple as possible, denominator is as simple as possible. No need to factor, nothing cancels there. Okay. So then step 2 says find the horizontal or slant asymptote. Okay, this one, my numerator is a 3x, my denominator is x plus 4. They are of equal power. So that's going to give me a horizontal asymptote. And when I'm looking at my horizontal asymptote, I'm just going to look at this right here, essentially what's up top. So that's going to be like y is equal to 3x over x. Those x's would cancel out, reducing it to just 3. So what I want to do is at y equals 3, I'm going to put a horizontal dashed line. When you're drawing your asymptotes, please make them dashed. So where's my line tool? And let's change the color. I was using purple. So y equals 3. I have my dashed line. So it just went up, y equals 3, horizontal line. Now the next step set the denominator equal to 0 and solve. That is your vertical asymptote. So for my vertical asymptote, I can say, oh, my denominator, x plus 4 equals 0. That's rather simple to solve. Let's subtract 4 from both sides. And we get x equals -4. Now again, this is a vertical asymptote, so at -4 on my x, I'm going to draw a vertical line there. Again, since it's an asymptote, I prefer these to be dashed. It gives me, as the person looking at the graph, an indication that, wait, these lines actually aren't part of the graph, but they're critical for drawing the graph. So that would look something like this. Now I just need to figure out where it curves along. That's where I'm going to utilize Desmos sum. Usually a rational function like this will be down in the lower left corner and the upper right corner. That's what my gut's telling me. We could plug in values to see, but if we got a graphing calculator, let's just utilize that. So let's see, I have 3x divided by x plus 4. And I was indeed, oh no, I was wrong. I had said lower left and upper right. This is in the upper left and lower right. So that's how I'm going to graph this. The one line is going to be along this side, and this one is going to be along the bottom. So my quick graph will look something like so. Please do not cross the asymptotes. You want it to go right up to them, but I'm going to actually redraw this bottom one a little bit sloppy. If I see something like this, where it clearly crosses both asymptotes, I have to take off points because it should ride along the asymptotes. This is no good. Let's get rid of that and draw it better again. So again, I'm going to go right along the asymptotes, but do not cross them. So that's graphed by hand. If you like how it is graphed by hand, you're like, that's not too bad, I can handle that. Go right ahead and graph it by hand. If you're saying, I don't know, I'm getting into the technology, I like utilizing that. This graph here would not give you full credit. What I need to see are our asymptotes. Now, we already figured out what those were. We said y equals 3. There we go. Now, the other one, we said x equals -4. Now, what we need to do is get these as dashed lines. I do prefer these as dashed. So we can hit the gear here and click on the blue line, switch that over to dash. Click on the green line, switch that over to dash. Now, again, if you want, we can zoom out a little bit to see more of what's happening. And again, as I really zoom out, I see it just wants to approach these asymptotes. So right now, I'm going to take a brief pause based on the looks I'm getting inside the classroom. I think we're getting some understanding of this, but I want to make sure those of you that are here virtually, since I'm not seeing your face, that you have time to get questions in. Asymptotes need to be there if you're doing this on Desmos. That is something I will look for every time. And when it comes time for the quiz on Friday, if you give me a graph on Desmos without the asymptotes graph, that is going to cause a minor issue. Okay, not seeing any questions come up virtually either. So let's talk about a slant asymptote. A slant asymptote happens when the numerator has a higher power. To find the equation of the asymptote, we divide the equations. So we're just either going to use polynomial or synthetic division. Like I said, I believe every problem I have you do that involves a slant asymptote can be done using synthetic division. So hopefully that makes life a little easier for you if you just have to deal with synthetic division. So we got two more examples here. Going to look at graphing this one. I believe this one should have a hole in it. And then we're going to graph this one, which will have a slant asymptote. So here with this, first thing we want to do is factor. So here, I realize x squared minus 9, that factors to an x plus 3 and x minus 3. So if I were to FOIL that out, I get my middle terms to cancel, hence why there's an x in the middle, and 3 times -3 gives me a -9. Now again, I want to factor here. -3 add to -2, so that should be x minus 3 times x plus 1. Now I notice x minus 3's cancel, leaving me with a final equation of x plus 3 over x plus 1. However, this tells me I have a hole when x minus 3 equals 0. So add 3 to both sides and we get x equals 3. So at the x value of 3, you need a hole. What most students do and what I kind of recommend is you just draw your curves nice and smooth using a pencil. This way you can just erase where 3 is at x. You just erase that, draw a hole, and now you're good. Okay. Now I'm going to look for my horizontal asymptote. I know it's a horizontal because they are of equal power. So that was purple. Actually, let me get my graph ready to go over here. 5, 4, 1, 2, 5, 1, 2, 4, 5. Wanted to get that ready to go. This way I had the space for it and don't mess it up. Okay, so here with this, looking at my leading coefficients, that will give me a horizontal asymptote when y is equal to x squared over x squared. X squared over x squared conveniently reduces to 1. So at y equals 1 is my horizontal asymptote. Let's draw it. So I just draw a horizontal line at y equals 1. I know where my hole is going to be. We'll see how to deal with that in a second. Now, the last part is set the denominator equal to 0 to find our vertical asymptotes. So my vertical asymptote here will be x plus 1 equals 0. When I subtract 1, I get x equals -1. So at -1 on the x, I draw my vertical line. And now I just need to see, hey, is it going to be my upper left and lower right, or is it going to be lower right and lower left and upper right? So now I'm going to utilize Desmos to help me with the last part of the graphing, but I know when x is equal to 3, I need to have a hole there. So let's take a look at Desmos. Okay, so I'm gonna delete these out for now. Actually, no, I'm just gonna change them to what they are because I'm gonna need to put them in anyway. So that's y equals 1 and x equals -1. So we can see these two asymptotes are clearly wrong for the previous graph. So let's get this edited to be the correct graph. So it said x squared minus 9 over x squared minus 2x minus 3. There we go. So this one's in my lower left and upper right. Again, if I'm looking for my point here, I will get that it tells me that 3 is undefined, meaning there is a hole there. So here's what I'm going to do. So I know it's in that upper right. I'm going to put my last surface in green, a hole at 3. And again, I just go like so. Notice I just have it jump over the hole. And there we go. That is graph by hand. Please notice I included the hole in our graph. So I just put an open circle when x is 3. So where x is 3, just left a little gap there for my hole. Any questions about this one? We got one more example. This one will deal with a slant asymptote. Slant asymptotes are a little bit tougher. You are basically going back to graphing the equation of a line. So you're going to do slopes rise over run, things like that. And yeah, let's get going with it. Okay, here, the numerator is a square where the denominator is not. Forgot about that. Get that on this afternoon. So I can see if anything cancels here when I do this. This is just going to be x minus 2 times x plus 1 over x minus 1. Nothing cancels, no holes. So here's what I'm going to do for my slant asymptote. What we are going to do is divide these using synthetic division. So that's, since it's a -1 here, remember that flips to a +1. Then I have a coefficient of 1, -1, and -2. Okay, bring down the 1, that's 1. 1 times 1, that's 1. -1 plus 1 is 0. Bring this back, and that would be 0, so that's -2. So here, this would give me basically the following equation. X plus 0 minus 2 over x minus 1. So this equation, and this equation, all three equations here will give us the same graph. They are all equivalent. However, this right here actually tells me the equation of the slant asymptote. So I'm just going to abbreviate that SA is y equals 1x plus 0. Now I'm writing it that way so it's very obvious what my b is, 0, and what my b is the y-intercept is 0, and it's very obvious that my slope is 1. Now I just need my vertical asymptote. So for my vertical asymptote, I still say, hey, x minus 1 equals 0, add 1, x equals a positive 1. Okay, let's go with sketching this now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4, 2, 3, 4. There we go. What I'm going to do is I'm going to start with my slant asymptote. Actually, let's put the points down first. So my y-intercept 0, that tells me to go up 1 over 1. Going to put 2 more points there following that slope, just to give me a better bearings with it. But this is really just graphing the equation of the line here. So there we go. That's pretty good. That is my slant asymptote. Now let's draw my vertical asymptote at x equals 1. And now I need to see, is it in the two skinny parts, or is it in the more where we have that obtuse angle being formed? So it's either going to be, again, upper left, lower right, or lower left, upper right. So let's take a look in Desmos and see. So I get the original equation of the graph. X squared minus x minus 2. And then the bottom was just x. Yeah. Okay, big fraction. X squared minus x minus 2 over x plus 1. No, x minus 1, sorry. Minus, there we go. So there we go. We see it on the two outer parts. I'm going to add the asymptotes in 1 second. But our graph looks something like this. And that's it. So let's go back to this. I had y equals 1x plus 0. Oh, now that asymptote looks right. And then the other was x equals a positive 1. And hey, as I zoom out, it's looking to still hold true. So what's happening here, just to get a little deeper into this, is when you divide them, it's essentially saying that the equation, this equation here, when you divide, is x or 1x plus 0 with a very small remainder. The remainder is causing the funny activity in the middle around the vertical asymptote. But outside of that, it wants to conform to this slant asymptote of y equals 1 plus x. So once we get away from where we divide by 0, the graph really wants to try and be this equation here, hence why it's just right along that slant asymptote. Okay, so that is all we have for this. For your homework, we got on pages 157 and 158, 18 through 24 even, then 56 and 62. So that's 18, 20, 22, 24. So that's 6 problems for you to graph. That is your homework. Please make sure you are trying that tonight. This way, tomorrow I can take any questions we have on it. Wednesday, we do our usual check-in, make sure any last-second questions are answered, and then we're ready to go for the quiz. Quiz review on Thursday, and the quiz itself will be on Friday. If you can do well on this homework, you can do well on the quiz. If you're struggling with the homework tonight, please make sure to let me know where we need help and support. So I will stop recording. I will make sure to post this later